Good day. So in this video, we are going to look at the whole chapter of calculus in grade 12 mathematics. And I want to assure you that after this video, you are not going to fail calculus anymore. And you're going to improve your understanding. And you come to realize that calculus is one of the easiest chapters in mathematics. So yeah, without wasting time, let's get into it. So we're going to look first at the first principles of differentiation. Now, before we look at the first principles of differentiation, you recall very much that if you are given 2 points on a Cartesian plan, let's say point A and point B, with the coordinates x1 and y1, and also the coordinates of B as x2 and y2, so these 2 points can be joined with a straight line, then you know very well that the gradient of the line AB, which is MAB, the gradient of a straight line from your analytical geometry, will be equal to your y2 minus y1 divided by x2 minus x1, which some other people, they just want to say the change in y over the change in x. So yeah, with that in mind, let's look at this graph here. Now, let's suppose you are given a curve. So the difference between a curve and a straight line is that with a straight line, there is a constant gradient. That's why you can use this equation for a straight line to calculate only one single value for the gradient. But with a curve, the gradient differs along the curve, so it changes. But we can be able to determine what we call the gradient function using the differentiation. So now let's suppose on this curve, which is the f of x, you are given the x coordinate, and let's call it x. And obviously, then your y coordinate, it's going to be the function of x. Now, let's say this value of x is increased by a small value of h. So this h can be like 0.001 or 0.0001. So in short, h is a very small value. So therefore, the new coordinate of x will be x plus h. So this x coordinate plus the h, which is the small increment. Therefore, the f of x or the y coordinate will be the function of x plus h. So now we have got 2 points that are joined together, and these points are close to each other such that this becomes like AB becomes like a straight line. So with that, we can be able to determine the gradient of AB. Again, now MAB from the curve will be equal to, so this will be like your x2, and this is y2, then this is x1, and this is y1. So we can say now this is equal to y2, which is the function of x plus h, minus y1, which is the function of x, divided by x2 minus x1, which is x plus h minus x. And this can be simplified further to be the function of x plus h minus the function of x, then at the bottom divided by h, because those x's, they cancel each other. Remember, we said that the value of h is a small value. So that's why we limit the value of h and we say that h is approaching 0. So this is how you can determine the gradient function on a curve. So this is what we call the first principle of differentiation. So this is the formula that you use for the first principles. Now, let's look at the example. Now, in this example, we are asked to calculate the first derivative. So this symbol here, it means that the first derivative of x. So we are asked to calculate the first derivative of x for the function f of x is equal to 4x squared using the first principles. So guys, if you are asked to use the first principles, make sure you use the first principles. If you use any other methods of differentiation, you are going to get a 0. So the first principles formula states that the first derivative of x is equal to, first of all, limit h approach 0, then function of x plus h minus function of x divided by h. So yeah, what you want to determine here is just the function of x plus h, because you already have the function of x, which is equal to 4x squared. Therefore, the function of x plus h will be, so you just substitute x plus h on x. So that will be 4 bracket x plus h bracket squared. And then you can just simplify this further, and that will be 4 bracket x squared plus 2xh plus h squared. And this can be simplified further to be 4x squared plus 8xh plus 4h squared. Now, with that in mind, so we can actually now substitute all these values into this formula. So then we don't drop our limit yet. So we say lim h approaches 0. The function of x plus h is the whole thing here. So we rewrite that thing, which is 4x squared plus 8xh plus 4h squared minus the function of x. The function of x is just this function here. So that will be minus 4x squared. Then all divided by h. And this will be simplified further to be lim. You don't drop your lim. You only drop your limit when you substitute h for 0. And at this point, we can't substitute h for 0, because if we put h at the denominator here, that will be undefined. So if we divide any number by 0, that will be undefined. So in this case, this 4x will cancel, and we'll just be left with 8xh plus 4h squared divided by h. Then we factor out the h on the numerator. That will be lim h approaches 0. Then we factor out h bracket 8x plus 4h divided by h. Then the h, they will cancel. Then in the last step, we substitute h for 0, because we are saying h approaches 0. So we substitute h for 0, and then the answer will just be 8x. So what it means is that the first derivative of the function of 4x squared using the first principles is 8x. And I hope that makes sense. Now, moving on to the rule of differentiation. Now, the rule of differentiation, this is the simplest way of differentiating a function. So let's suppose you've got the function f of x is equal to x to the power of n. So to find the first derivative of this function, the first derivative, which is symbolized by f prime x, will be equal to, you just drop the n to the front, and that will be nx, then you minus 1 on the numerator. So it will be nx to the power n minus 1. Like for example, we're using the previous example, we say that find the first derivative of x if the f of x is equal to 4x squared. Now, applying this formula, we just say the first derivative of x will be equal to, so you drop down the 2 and it multiplies with the 4, and that will be 8x. Then we minus 1 on the power, and that will be 8x to the power 1. And if you remember very well, in the previous example, we got the first derivative of 4x squared as 8x using the first principles. And when you use the rule of differentiation, you also get 8x. And this is the easiest method. However, one thing that you need to know about the rule of differentiation is that the derivative of a constant, so if you have got a function of x is equal to, let's say, x squared plus 2. So the derivative of that constant here is 0. So the derivative of this will just be equal to 2x, because the derivative of a constant is 0. Now, the other thing that you need to remember as well in this, when you're differentiating using the rule, is that when you have got a square root, let's suppose you've got a square root, don't differentiate the variable if it is under the square root. You have to apply the laws of indices, and that will be f of x is equal to x to the power a half. Then you can go ahead and differentiate, and in this case, the first derivative of x will be equal to, you bring down the half, it will be half x to the power half minus 1, that will be negative half. Again, the other thing that you need to take note of when you're doing differentiation using the first rule, if you have got a function of x and x is at the denominator, your variable is at the denominator, again, do not differentiate when the variable is at the denominator. You want to bring that variable to the numerator by applying laws of indices, and that will be f of x is equal to x to the power negative 2. Then you can go ahead and differentiate that, and the first derivative of x will be negative 2 x to the power negative 3, because you minus 1 again on the power. Again, the other thing that you don't want to do is that if you have got a bracket, so if you have got x plus 1 and x plus 2, you don't want to differentiate when the variables are in a bracket like this. So you want to first of all expand these brackets, and that will be x squared plus 3x plus a 2. Then you can go ahead and determine the first derivative of x, and that will be 2x plus a 3. And remember, the derivative of constant is a 0. So the first derivative of that function will be 2x plus 3. Now, with that in mind, let's look at some examples. Now, in this first example, we are asked to determine dx bracket x squared minus 2x minus 3. So this is another way of saying find the derivative of x of this function, which is in this bracket. In this case, that is 2x, that is x squared minus 2x minus 3 over x plus 1. So the first thing that you want to do, remember we have got now a variable at the denominator. And when you have got x plus 1 like this, you can be able to factorize the top part so that you cancel with the bottom part. Then you can differentiate. So let's go ahead and factorize the top part. So the top part will be x bracket, x bracket, and a square bracket. So then the factors of negative 3 here, that will give us, when we add them to give us negative 2, will be a 3 and a 2. So that will be a 3, not a 3 and a 2, a 3 and a 1. So to get negative 2, we say minus 3 plus 1. Then we divide that by x plus 1. So you see, now there is a factor on top that can cancel the bottom part. So we can cancel now x plus 1 and x plus 1. So in simpler terms, we are asked to find the derivative of x minus 3. And the derivative of x minus 3, it's like we have got x to the power 1 minus a 3. So then the derivative of that, we bring the 1, so that will be 1. Then we say 1 minus 1, that will be 0. So x to the power 0 is a 1. Any number raised to the power 0, it's a 1. So therefore, the dx of this function will be equal to 1. Now, in the second example, we are asked to determine, you see here, that is the second derivative. So you differentiate 2 times if function of x is equal to the square root of x. Now, what you want to do first, remember we said in the previous slide, we say that you cannot differentiate when it's under a square root. So one thing that you want to do, you want to convert that to be a power. So that will be f of x is equal to x to the power a half, using the laws of indices. So then you can go ahead now and differentiate that. And the derivative will be half x to the power negative a half, because you minus 1 on the power. But this is only the first derivative. And remember, you are asked to find the second derivative. So you can go ahead now and differentiate again this first derivative to get the second derivative. Once again, you bring the negative half now. It multiplies, so that will be negative half multiplied by a half. Then x to the power negative half here, then minus a 1. And that will give us negative a quarter, then x to the power negative 3 over 2. And that is the second derivative of the square root of x. Now, moving on to the last example. In here, we are asked to determine dy dx. So dy dx is also the derivative of y over with respect to x. So then the dy dx of this function of y is equal to 4 cube root of x bracket 3x cubed squared. So to do this, first of all, remember, you want to remove that root. So to do that, we apply the laws of indices, and that will be 4x to the power a third. And you also want to simplify this bracket, and remember, we just bring the 2. So the 3 gets raised to the 2, and also this 3 multiplies with the 2. And that will be now 3 squared, it's a 9. So that will be 9x to the power 6. Now you can go ahead and find the dy dx. So you make sure that you only write dy dx when you do the derivative. You don't write dy dx at this point here. So you only write when you do the derivative. So the dy dx will be, so you bring down a third, so that will be a third multiplied by 4, then x to the power a third minus 1, that will be negative 2 over 3, then plus, then you bring down the 6, that will be 6 times 9, x to the power 5, because you say 6 minus 1, and that will be equal to 4 over 3, x to the power 2/3, negative 2/3, then plus 6 times 9, that gives us 54, then x to the power 5. And this is how you find the derivative of 4 cube root of x bracket 3x cubed to the power 2. Now, let's move on to the equation of tangents. Now, before we move on to the examples in determining the equation of tangents, let's just discuss what a tangent is. So you remember very well, a tangent is a line that is drawn like outside of the curve, then it touches the curve once. So this is a tangent. So it is a straight line. So this line is a tangent. However, if you have got a line that is drawn like that, that is not a tangent. That line is a secant. So that is not a tangent. A tangent, remember, it only touches once outside the curve or a circle. So this automatically tells us that the equation of a tangent is of a straight line, and you know that the general equation of a straight line is y is equal to mx plus ac. So what we simply need is the gradient at this point of intersection of a curve and a tangent. Then if we get that gradient, then we can also determine the value of c if we know or if we are given any point on the straight line. So yeah, let's look at an example. Now, in this example, we are asked to determine the equation of the tangent to the graph of g of x is equal to negative 3x squared plus 2x at the point 3 and negative 21. So we have got a curve and we are asked to determine the equation of the tangent at the point 3 and negative 21. So remember, we said that the equation of a tangent is y is equal to mx plus c. So we just want now to find the gradient at this point. So to determine the gradient of a curve, first of all, we find the derivative of the curve. So in this case, our curve is negative 3x squared plus 2x. Then the first derivative of that, which will give us the gradient function, will be equal to negative 6x plus a 2. So this is our gradient function. And if we substitute any value of x into that gradient function, that will give us the gradient at that value of x. So in this case, the value of x that we have is a 3. So if we substitute 3, we will get the gradient at 3. So that will be m at 3 will be equal to negative 6 bracket, we substitute on the x value, then plus a 2. And that will give us negative 16. So that tells us the gradient of a tangent at x is 3 and negative 21 is negative 16. So now we have the gradient. So we just substitute the gradient in here, and that will be negative 16 x plus a c. Now we want to find the value of c. To find the value of c, we just substitute the whole point. This is the point of intersection of a tangent and a curve. So we substitute that point as x and y, and then we get our c. So y is negative 21 is equal to negative 16, then bracket 3, then plus a c. Then we'll see that c is equal to 27. And now we have our c. We can write down the equation of the tangent, which will be y is equal to, remember, our gradient, negative 16x, then plus a 27. And ladies and gentlemen, that is how you determine the equation of a tangent. Now, moving on to cubic graphs. Now, a cubic graph, these are graphs that have got x as the highest power. The highest power of x is a 3. These are the cubic graphs. So if every time when I've got a highest power of x as a 3, what results is a cubic graph. So if you have got a cubic graph, y is equal to ax cubed plus bx squared plus cx plus a d, and where a, b, c, and d are positive or negative constants, then what you have if a is greater than 0. So this is the general equation of a cubic function. So if this value of a here is greater than 0, when you sketch your graph, it will start off as a sad face, then it becomes like a happy face. And if it's a is less than 0, it is the other way around. So this graph should be starting with a happy face and going with a sad face. So it starts as a happy face, then goes as a sad face. So there are things that are needed to be calculated to sketch this cubic function, such as the x-intercept, the y-intercept, and the stationary points. So in the next example, I'm going to show you how to do the sketch of a cubic function. Now, in this example, we are asked to sketch the graph of y is equal to 2x cubed minus x squared minus 8x plus 4. Then we're asked to clearly show the axis intercept, stationary points, and point of inflection. Right. So before you sketch the cubic function, there are 4 things that are needed. Number 1, you need your y-intercept. So you need to determine the y-intercept. So remember, to determine the y-intercept, you let x is equal to 0. So if x is 0 in this function, you will see that the value of y will be equal to positive 4. So your y-intercept will be positive 4. Then the second thing that you need to determine is the x-intercept. The x-intercept. So first of all, the y-intercept and then the x-intercept. And remember, at the x-intercept, we let y equal to 0. So 0 will be equal to 2x cubed minus x squared minus 8x, then plus a 4. Then you can solve this. You can simplify. That will be 0 is equal to, in this case, we factor out x squared at the beginning. Then we are left with 2x minus 1. Then bracket, we factor out here negative 4. Then we are left with 2x minus 1. And 0 will be equal to x squared minus 4. Bracket, and 2x minus 1. And this can be simplified further to be x squared is equal to 4 and 2x is equal to a 1. And we can now say x is equal to plus or minus the square root of 4, and also x is equal to a half. Now x here will be simplified to be plus or minus 2 and x a half. So now we have our x-intercepts. The x-intercepts are x is equal to 2, x is equal to negative 2, and x is equal to a half. So these are the x-intercepts. Now let's just delete here and create some space to determine the maximum and the minimum point, which are the turning points, and also lastly, the point of inflection. So now the other thing that you need to sketch this graph before you sketch it are stationary points. So stationary points, these are the maximum and the minimum point, or the turning points. So one thing that you need to know, at the stationary points, the dy dx, which is the first derivative, will be equal to 0. So at the maximum point here, the first derivative is equal to 0, or at the minimum point, again, the first derivative is equal to 0. So now let's go ahead and find the first derivative of this function. So the dy dx will be equal to, in this case, that will be 6x squared, then minus 2x minus an 8. And remember, we equate this to 0. So 0 is equal to 6x squared minus 2x minus 8. And this can be factorized to be 0 is equal to 6x minus 8, bracket, and in a bracket, x plus 1. So we can say now x is equal to a 4 over 3, or x is equal to negative 1. So if x is 4 over 3, what is the value of y? So y will be equal to, so you take your 4 over 3, you substitute back into the original equation. You do not substitute into the derivative. Otherwise, it will be a 0. Then you realize that the value of y will be negative 100 over 27. And also here, if x is negative 1, you realize that the value of y will be equal to 9. Now we have got our stationary points. So our stationary points will be 4 over 3. So that will be 4 over 3. And so 4 over 3 and negative 100 over 27. And also the other point will be negative 1 and a 9. So we have now our stationary points. Then the last thing that we need to determine in this case will be the point of inflection. So to determine the point of inflection, we do the second derivative. And we let the second derivative be equal to 0. So the second derivative will be equal to 0 for the point of inflection. So we go ahead again and differentiate that function. So the second derivative is symbolized as d squared y over dx squared. And that will be equal to 12x minus a 2. So that will be 12x minus a 2. And we say, remember, at the point of inflection, the second derivative is 0. So then 0 will be equal to 12x minus a 2. And we can actually say now 2 is equal to 12x. Then we divide by 2, divide by 12, and divide by 12. So x will be equal to 1/6. So the point of inflection, the x coordinate will be 1/6. And you can also go ahead and determine the y coordinate by substituting 1/6 into the original equation. So yeah, now when you have got all these points, you can be able to sketch your cubic function. Now, after you've substituted 1/6 into the original equation, you get your y coordinate as 143 over 54. So that will be the point of inflection. Now, with all these points, the y-intercept, the x-intercepts, the stationary points, and the point of inflection, now we can be able to sketch the graph. So we go ahead and draw our x and y-axis. And first of all, we put the y-intercept. Then the y-intercept is a value of 4. So let's just use a different color. So that will be a value of 4. That will be the y-intercept. Then the next thing, we go ahead and insert our x-intercepts. So the x-intercept, it is a value of 2, negative 2, then a 2, and then a half. So a half will be somewhere here. That these are our x-intercept. Then the next thing that we want to go ahead and do will be the turning points. So the turning point, it's a 4/3, which is like 1,333, and also negative 100 over 27, which would be like negative 3.7 for the y value. So this coordinate will be just between half and 2, because that is 1,33. So it will be between this point and this point. So it will be somewhere here. Then we clearly label that point. That will be 4 over 3 and negative 100 over 27. So this is the first turning point. Now the other turning point will be negative 1 and 9. So negative 1 is somewhere here, and a 9 will be somewhere there. So that will be another turning point, negative 1 and a 9. So then you can actually join these points like that, and then you have got your cubic function. And these are easy, 5 marks. And the other thing that you can draw from the cubic function is that you can see that until this turning point here, the equation or the graph is increasing, and then it starts decreasing until the point of inflection. We forgot again the point of inflection, and the point of inflection will be here. That will be 1/6 and 143 over 54. So then it starts decreasing until here, and again it starts increasing from the turning point all the way to infinity. And you can see there it is concave down until the point of inflection, and also concave up from the point of inflection up to the positive infinity. And this is how you sketch the cubic function. Now let's look at how to determine the cubic equation from the cubic graph. Now, unlike the previous example where we were asked to determine to sketch the cubic function, in this case we have got a sketch of the cubic function, which is y is equal to x cubed plus bx squared plus cx plus d. and we are asked to determine that equation from the sketch. So we are also told that f of x is equal to 0. The solutions of f of x is equal to 0 are -2, 1, and 4. So what it means, if f of x is equal to 0, remember at f of x is equal to 0, those are x-intercepts. So we are literally given the x-intercepts, all of them. So that will be -2, a 1, and a 4. Right. So, and we are asked to find the values of b, c, and d. So before we do that, you remember the general equation of a cubic function is equal to ax squared cubed, plus bx squared plus cx, then plus a d. Where a is, remember, it just determines the shape of the curve. And also here, a is given already. So we have got a. So a is equal to 1. If you want to compare with that equation, a will be equal to 1. So a is equal to 1. Now, so if you are given the roots of a graph, be it a quadratic equation, and in this case, this is a cubic function. So if you are given the roots, you can determine the equation by saying y is equal to a outside, then bracket x minus root 1, bracket x minus root 2, bracket, if it is a quadratic, you end at root 2, because a quadratic function has got 2 roots. But this is a cubic, then you need a third root. So that will be x minus the root 3. So then you say y is equal to, in this case, we have got the value of a already given, and that is 1. Then that will be x minus root 1 is minus 2, so that will be x plus 2, bracket. Then the next root is 1, so that will be x minus 1, bracket. And the last root will be x minus 4, bracket. And if you go ahead and expand that, that will give you x cubed minus 3x squared minus 6x plus 8. And you can see now the value of b is the coefficient of x squared. So b will be equal to -3, and c will be equal to -6, and d will be equal to 8. And this is how you determine the cubic function from the cubic sketch. Now, moving on to the last point of optimization. Now, in this last section of optimization, which is also called the applications of calculus or maximum and minimum, we are now going to use calculus to solve real-life situations to get the maximum area or maximum volume or maximum length of a square or a rectangle or whatever example that you be given. So let's jump into an example. So in this case, we are given a rectangle with the length 2x and also 100 minus x. The first question, we are asked to give area of a rectangle in terms of x. So as you know, the area of a rectangle is equal to length times breadth. So in this case, a will be equal to the area, length is 2x, times the breadth. In this case, that will be 100 minus x. And then that will be equal to, so you can simplify this, that will be 200x, then minus 2x squared. So this is the area. Remember, we are asked to determine the area in terms of x. So that will be the area in terms of x. Now, moving on to part 2. For which value of x will this area be maximum, I mean. So for which value of x will this area be a maximum? So if you're talking of a maximum at a minimum point, remember, you find the first derivative, and at a maximum point, the first derivative is equal to 0, or at a minimum point, or the first derivative again is equal to 0. And we are asked here, for which value of x would this area? So we are going to differentiate the area function, and we equate that to 0 to get the value of x. So in this case, we continue and we find the first derivative of the function of the area, and that will be equal to 200 minus 4x. And then we go ahead and let that the first derivative be equal to 0 at a maximum point. So 0 will be equal to 200 minus 4x, and we'll see that x will be equal to 50. So this will be the value of x at the maximum point. Now, moving on to the last question. What is the maximum area? So now we just substitute the x value into the area function, or you can take the x value and put it into the dimensions. Then you can be able to determine what area is. But I will just take this and substitute into the area function. So area will be equal to, in this case, 200 multiplied by 50, then minus 2 bracket 50 squared. And you see that the area will be 5,000, in this case, units squared, because we do not know what units were they. So if they are centimeters, you just say centimeter squared. If they are meters, you just say meter squared. So this is how you use or apply calculus in determining the length of the sides or the volumes of shapes or prisms of spheres or cylinders. So yeah, this marks the end of this lesson. And let me know what you think in a comment section. And I wish you all the best. So bye for now.